In this video, we want to continue with the topic of variance or dispersion of the data. And here we're going to start with the coefficient of variation. So the coefficient of variation is the standard deviation divided by the mean and multiplied by 100%. So what does this really mean? It means the coefficient of variation is a measure of variation represented as a percentage, and it is relative to the mean. What is our formula for that? Well, then CV, our coefficient of variation, is the standard deviation divided by the mean times 100%, where again S is our sample standard deviation and X bar is the sample mean. Besides the coefficient of variation, there's one other type of variable that we want to talk about in this video, and that is the z-score. And this is something that's going to be used quite often. What is it? It is defined as the value x minus x bar divided by s. So what this tells us, the z-score of a data point, right? If we have some data point within a data set, the z-score of that particular data point is just how many standard deviations you are away from the mean. That's exactly what this does. You take the value x, so your data point, you subtract the mean, so you find the difference between your data point and the mean, and then when you divide by the standard deviation, that just makes everything relative to the size of the standard deviation. So it tells you how many standard deviations you are away from the mean. If this value is negative, it means you're below the mean. If the value is positive, it means you're above the mean. Okay, so I'll go ahead and write that in here now. This tells us how many standard deviations X is away from the mean. Awesome. And actually, I just want to mention a couple of things real quick about how data might look, and that'll finish up our definitions and talk on variance in this section. So earlier, we saw some data sets that look like this or this. Both of these kinds of data sets were symmetric about the mean, and this had a large variance, this had small variance. But now let's talk about what happens if it's not quite symmetric. So a set of data that looks like this is called left skewed. And here, the mean is less than the median in this kind of a data set. If we have something that looks like this, again, this is symmetric. And here the mean is equal to the median if it is perfectly symmetric. And if we have a data set that looks like this, well, naturally, based on what we just heard earlier, this is called right skewed. And in right skewed data, the mean is greater than the median. And that's actually where we'll end this video in this section.